Hi guys, in this particular discussion we're going to look at an extra process that occurs during radioactive decay, and this basically is the process of positron emission. Now in our earlier videos we had looked at the concept of trying to gain stability for this what we refer to as radioisotopes or radioactive elements. So in this particular case we had said that for an element to be stable it has to undergo some of these specific transitions that we mentioned, which are of course radioactive decay processes, and this is going to lead to the formation of a stable element. Now in between here we have looked at various processes which of course are measured as an alpha decay, which is a release of a helium nucleus, and then I mentioned the concept of a gamma. This is a radiation, and it is a form of energy, and I mentioned the concept of a beta decay, which basically we had looked at the beta positive and the beta negative kind of a decay, which are the processes which are going to be involved in trying to create these stable elements, and the process in between is what we had referred to as the decay process. Now in this particular case I'm going to look at a specific process which is going to involve the change of a proton to a neutron. And in this particular case, this is one of the processes that are going to be, of course, experienced in the nucleus. And this is going to lead to, of course, what we refer to as the concept of stability. Now, in some cases, we had mentioned that under the patterns of nuclear stability, we had mentioned that the ratio between the protons and the neutrons are very important. And this is one of the ways in which we are going to consider the element, whether it is of course stable or not. Now in this case, some analysis which has been done, there has been some statistics which have shown that the ratio between the nucleus and the ratio between of course the protons and the neutrons plays a vital role in trying to ensure that elements are stable, in a sense that whereby there is a case for light elements, the stability is going to be achieved when the number of the protons and the neutrons are approximately equal. Now in this particular case, we can be able to give this specific case whereby the equilibrium or the number of neutrons and the protons, whenever they are roughly equal for lighter elements, this is going to lead to the concept of stability. Therefore, that one implies that there has to be a specific ratio which has to be kept for an element to be determined as stable or not. But in this particular case, in the trends in our periodic table, we note that whenever the number of Z increases, we're going to see that the ratio between the protons and the neutrons are going to change. And for that case, the stability is going to be compromised. And this particular case, we have said that therefore that particular ratio that is going to exist between the protons and the neutrons has to be maintained at a particular value, in order to make sure that these particular elements are stable. So bearing that one in mind, then therefore that is going to play a role in trying to describe this particular concept of positron emission, whereby we are going to see that a proton is going to be converted into a neutron in order to maintain this specific concept of stability. Now in this case, we can be able to illustrate this one in terms of a nuclear equation, which is going to assist us, of course, understand how this specific process takes place. Now I've said that a proton is going to be converted into a neutron, and of course we are going to have this specific case now for this what we refer to as sorry for this is going to be given as one. So therefore this is going to be converted into what we refer to as a positron and then a neutron, and this is a transformation of the proton. Now in this particular case, of course, we have decided that basically we have some particles which we are going to regard as antimatter, and these are going to be of course the opposite, or rather the counter products, the counter particles of the previous ones that we have discussed. For instance, what we refer to as the beta decay, in our first case that we had given us this particular element, we had said this particular symbol, we had said that this basically represents an electron, which is going to consist the charge as an electron and the mass of an electron. Now in this particular case, we try to look at this is going to be an electron, but which is going to be positively charged, and therefore if this is if we can regard this one as a matter particle, and therefore the positron is going to be an antimatter particle in this particular sense. So if this one is an electron, then therefore this is going to be an anti-electron, which is going to be, of course, referred to as a positron. And therefore, by definition, we can be able to regard as a positron as a particle with the same mass as an electron, but with a positive charge, or an antimatter version of an electron. And we can be able to give an example of this particular positron emission using one of the elements that we can be able to give, just like if we have sodium-22 with an atomic number of 11, this one can be converted to this particular element, which has got 22 and 10, and this is going to have what we refer to as a positron emission given as such. So in this particular case, I've stated that we can be able to give this specific notation using this, either this symbol or the one that is above, so that we can be able to illustrate this specific process. So the transition between sodium and this specific element, which is a neon that has got an atomic number of 10, can be able to be illustrated using this nuclear equation, whereby we're going to experience what we refer to as a positron emission. So this is going to be, of course, explained using various other examples that maybe I can be able to give on the board. And in this specific nuclear equation, we're going to see that the sum of the protons, or the atomic number that I've given on the left side of my equation, is equivalent to the sum of the atomic numbers of this particular positron and the daughter nuclide, or the daughter nucleus that has been achieved from this specific process. So therefore, we are going to see a balance of those specific numbers that I've given on the board. And therefore, the identity of this element that we are trying to illustrate in this specific case, of course, we are going to have a proton which is less than one proton, as I've shown it using this specific mass number and atomic weight and the mass number as I've given on the board. Now we can give various examples for this specific transition for positron emission. And in this particular case, I can give a transition between carbon, this is the carbon 11, which is of course undergoing this particular process of positron emission. And this is going to result in the formation of boron, and then we're going to have this positron emission given as that one. So in this case, if you try to look at the balancing of these numbers that are mentioned, of course, it's going to be the same. Now, in this case, if I had mentioned the concept of a transition from a proton to a neutron, then therefore we are given in our first video various characteristics insofar as charge and masses of the subatomic particle is concerned, and we had said that if we're going to give this mass in terms of a unit, then therefore the proton, neutron, and electron ratio for these specific masses are going to vary in some specific degree. So therefore, the mass of the proton and the neutron are roughly the same, but for the electron, it's going to be slightly lower in terms of quantity. So therefore, if there is a transition from a proton to a neutron in the nucleus, and therefore this neutron is going to possess the same mass, so the transition in mass in this specific nuclear equation therefore is not going to have an effect in this specific case for positron emission, and therefore this particular equation is going to appear as I've given. Now we're going to see that this concept of a positron emission is going to have various applications in our day-to-day lives, especially in the medical field, where we're going to have what we call positron emission tomography, which is going to be highly applicable, especially in trying to do some scans in the medical field. So this is one of the applications we are going to find this concept of a positron emission, and we're going to discuss that one in details when we come across that specific application. So in this particular case, I'd like to request us to check in our comment section, or rather in our description boxes, for a link of other videos which are related to this, especially on the radioactive decay processes, which I'm going to put there. So catch us in our next videos. We're going to look at the concept of electron capture, which is going to supplement on this specific discussion and give us an insight on how these radioactive decay processes occur. So for that case, I'd like to stop there. Catch us in our next video and kindly subscribe to our channel so that we can be having a healthy discussion amongst ourselves on these various topics in mathematics, physics, chemistry, and biology. So that is it for now. Bye guys. God bless you.